Let's have work problem. Work problem. So this is something to do with a formula which is very similar to your DRT. Work is equal to rate times time. Okay, so that means you can also use this formula triangle, work, rate, times time. So there are three formulas that we can create from this formula triangle. Work is equal to rate times time, rate is equal to work over time. What do you think is time equal to? Time will be equal to work over rate. Did you see that? Three formulas that can be formed. Work is equal to rate times time. Rate is equal to work over time. And time is equal to work over rate. Right, so three formulas using that formula triangle. Let's see which one of those three formulas is applicable in this problem. So here's our first problem here. A water tank can be filled by an inlet pipe in 6 hours. It takes twice that long for the outlet pipe to empty the tank. How long will it take to fill the tank if both pipes are open? Okay. Let's represent the time it takes for both pipes to fill the tank. All right, so let's use our blueprint. Let x, let's say let x be the time to fill the tank if both are open. So do you see the scenario here? The scenario is you have an inlet pipe, it fills the tank. But here comes the outlet pipe that drains the tank. If both pipes are open, one filling, one draining, how soon before it fills the tank? You see that? It seems like there's a leakage, but there's a something you're filling and at the same time you're draining. But of course, the inlet pipe is faster, right? Faster. So let X be the time to fill the tank if both pipes are open. How about the time it takes for inlet pipe? All right, 6 is the time for inlet. How about the time for the outlet? Twice. What do you mean by twice? 2 times what? 2 times 6, which is equal to 12. And this is the time, right? So let me put here hours, hours, hours. This is 6 hours. This is 12 hours. What's this 12 hours? Time for the outlet. 6 hours, the time for inlet. 12 hours time for outlet because it says twice. So these are the times that we have: 12 hours, 6 hours, X. X if both are open. So if inlet pipe is open alone, it can fill the tank in 6 hours. With 12 hours, this is the time it takes for outlet to fill or drain. Drain, right? It can drain the tank in 12 hours if it's full. Okay, so there's an inlet pipe that's filling the tank, and there's an outlet pipe that's draining the tank. And then we have X here. It's the time for both the inlet and the outlet pipe. If both of them are open, it takes X hours before the tank is filled. Okay, 100%. With these times, we can now find the rate. What's the rate? What's equal to rate? Rate is equal to, all right, this is your rate. Rate is equal to work over time. All right, so that's our formula there. We need this in order to find our equation, right? So your rate is equal to work over time. Work is equal to the number of work done. What's how many work is done here? Only one work, right? And that one work is to fill the tank 100%. So work here is equal to 1. And so the rate for both pipes would be 1 over the time, which is x. So it's easy and funny because when you write the rate here, it's simply just getting the reciprocal. But actually, it's not just getting the reciprocal because we know that there's only one work done here. And what is that one work done? Your work here could be 1, it could be a fraction. But since the work here is to be done 100%, and that is to fill the tank, so work here is equal to 1, so 1 over time. And so if you get this rate will be 1 over x, 1 over 6, 1 over 12. This 1 over x here is the rate for both. Rate for both. Rate for both. 1 over 6 is the rate for inlet. And 1 over 12 is the rate for outlet. Wow, that's just the first step. Okay, let me repeat that. A sink can be filled from the faucet in 10 minutes. It takes only 6 minutes to empty the sink when the drain is open. If the sink is full and both the faucet and the drain are open, how long will it take to empty the sink? All right. So let's try to represent the unknown. What's your unknown here? Right, let x be the time to empty. If both are open. All right, so let x be the time to empty the sink if both are open. Which one is faster here? Is it the filling or the emptying? It takes 10 minutes to fill, right? It takes 10 minutes to fill. It only takes 6 minutes to empty. So which one is faster? Empty or filling? Emptying or filling? Emptying is faster, right? It's faster. Faster than the filling of the sink. Therefore, in order to find our formula, it would be a different way around. But before that, let's try to represent the rate. All right, so what's the rate in filling? What's the rate in filling? The time it takes is 10. So what's the rate in filling? It's 1 over 10. Okay, rate in filling. All right. The rate in filling is 1 over 10. How about the rate in emptying? 1 over 6. Where do we get the 6? It's here, 6 minutes. So let that be a rate in emptying. How about the rate in if both are open? One over x, rate if both are open. Rate if both are open. Let's find our equation based on the idea that emptying is faster than filling. So since the rate of emptying is faster, then the formula there should be rate. Okay, let me just make it shorter because I have to do it shorter, right? Empty plus fill minus fill equals both. You should know which one is faster. Emptying is faster, so that means it's bigger. It's bigger. Empty is, faster, so that's bigger than the filling. So what's the empty? It's 1/6. What's the filling? What's the fill? 1/6. No, 1/. 1/10 equals both 1/x. All right. So remember that when you're trying to come up with a formula for work problem, you should know which one is faster, slower, especially if there's an emptying and there's a filling. There's a joining and there's a filling, right? So it's 1/6 minus 1/10 equals 1/x based on the idea that emptying is faster than filling. So emptying should be the bigger rate, higher rate. And we cannot do filling minus empty here because emptying is higher in terms of speed. If you switch that, you will have a negative answer here. We are avoiding a negative answer. So let us solve this equation now. One over 6 minus 1/10 equals 1/x. Let's look for the LCD of 6, 10, and x. What's your LCD for 6, 10, and x? Anybody now? Anybody now? LCD of 6, 10, x. Let's have 6 and 10 first. What's the LCD of 6 and 10? Oh, that's the GCF. How do you find the LCD again? You can do it by listing or by prime factorization. Let's do that. 6, 10. What are the factors of 6? 2 times 3. This is another method, but you can do the other method later on. How about 10? You have 2 times 5. But this is only a box for 2. This is a box for 3. Where shall we put 5? In another box. Now we simply bring down 2, 3, 5. 2 times 3. 6 times 5, you have 30. That's one method. Or you can do skip counting. You have 6 plus 6 to get the multiples. 12 plus 6, 18 plus 6, 24 plus 6, 24 plus 6, 30 plus 6, 36. How about 10? 10 plus 10, 20 plus 10, 30. You have 30 as the LCD. It's the same LCD, right? No matter what method you use, you'll get the same answer. So now let's multiply this by what? Multiply by 30x. Okay. So everything here multiplied by x, i.e. 30x. So this is times 30x times 30x times 30x. All right, what is 30 divided by 6 here? 30 divided by 6. 30 divided by 6, 5. 30 divided by 10, 3. Cancel your x. So now we multiply what we have left. What do we have here? 5 times x times 1 is 5x minus 1 times 3 times x, 3x equals 1 times 30, 30. 5x minus 3x, we have 2x equals 30. Divide by 2. Now your x is 15. What's the unit? Hours, minutes. All right, minutes. All right, so we have 15 minutes. So it means that if both are open, the sink will be empty in how many minutes? 15 minutes. That's a different case with our previous problem, because the previous problem is asking for how long will it take to fill if both are open. In that case, filling is faster than emptying, right? But here, emptying is faster than filling. So there would be nothing left in the sink because emptying is faster than filling. All right. So it will be 15 minutes. If both are open, imagine that there's a sink, it's full. I mean, maybe it's full at first, but then there's that empty. I mean, a pipe that empties it, which is a faster rate. Of course, there will come a time that the sink will be empty because emptying the sink is faster than filling the sink. Right. So that's our